Okay, make sure you have your notes out from yesterday, what we did in class, and for homework last night, because those will give you some ideas as to things to try. And this first one here, I'm just going to take a shot and rotate this and see what happens. So after I rotate it with my patty paper, I end up just about there. And I now can tell that I'm going to have to reflect it. I just want to have it easy for me to reflect. So I'm thinking, where can I translate this to make it easy for me to reflect? So maybe I'll just move it up on the other side of the x-axis. And then I can say my last step would be just reflect over the x-axis. And don't forget, if you found another way to do it, and ABC maps onto DEF, then you're probably right. There's lots of ways to do this. I'm just giving you an idea. In this next one, you're going to want to write this congruent statement at the top, because otherwise it's too symmetrical and you wouldn't know if you're right or not. So if ABCD is congruent to UVWT, then A has to map onto U here. A has to map onto U. So the only way that will work is if we rotate with your patty paper this way, right around the origin, and it falls, A does fall right onto U, so that one must be right. So a rotation around the origin, 180 degrees. A quick hint on this one, the first thing I'm going to do is try to translate it to make it look like a mirror image of P and M at the top. So I'm going to slide it over and down. You can count that yourself. But now I clearly see that I am reflecting over the x-axis. So a translation of you tell me and then a reflection over the x-axis would get this one done. Your first instinct here is rotation, and you're right because it's turned a little bit. It's just a matter of which way are you turning and is it the origin. So I tested out my plus sign at the x-axis with the patty paper, and I'm going to turn it to the left, which is positive, quadrant 3 to quadrant 4, and it does map perfectly on to the other triangle. So rotate 90 about the origin. I won't say transformation words on this one. I'll just show you what I think worked for me, and then you write down the actual transformation. This pentagon's a little tricky because you can see side KJ is slanted a little bit and side MN is vertical. So they almost look the same, but they're not. And those have to match up with the ones on the other side. So the first thing I did was try to rotate this clockwise, which is negative 90 about the origin. And I ended up over in this area here. Now it's sitting the same way as the one below it, and I can just translate it down. You figure out, after the negative 90, what is the translation? On this one, use your patty paper to test out how this rotates. It's not equilateral, but it's a little bit too close to equilateral to be easy to see. So I just turn it around the origin, and sure enough, it falls right onto itself with a rotation of 90 about the origin. I mean, at first glance, this one looks like a reflection over the x-axis, but if you look closely, there's more space below the x-axis than there is above it. So you just have to make sure the line is in the right spot. The line of reflection is not the x-axis. It's got to be one down from that, so you have 3 above and 3 below. What is the equation of that line? That line cuts through what axis at what number? This looks like something to do with 180, but it's not perfectly symmetrical to the origin. So I'm going to first do a 180 rotation and see what happens. It ends up in that area over here, and then you're going to have to translate it somehow. But at least now it's sitting the same way. So rotate 180 with your patty paper and then tell me what the translation is after that. On this problem here, I really didn't know where to start, so I just translated it because I didn't like how one was overlapping the other, and if you separate them a little bit, sometimes it's easier to see. So put your patty paper over the top. I just translated it until I noticed that, oh, I could put B together, and then if I went down one and down one more, then it's nothing more than a reflection over the x-axis. That's one way to do it. You have to tell me how far did you translate it, over and down, and then what is the reflection exactly. Okay, some of the remaining questions look very similar to yesterday's. Some might line up exactly with a little bit of a difference here and there. But on number 11, triangle on the left, ADC, they're telling you it's congruent to BDC on the right. So what rigid motion would map the left one onto the right one? And that would be a reflection of triangle ADC over line CD such that A maps onto B. This one tells us that DEF is congruent to GEH. What's the rigid motion that maps it onto it? You rotate triangle DEF about E, which is the center of rotation, such that F maps onto H, or such that D maps onto G. Either is fine. 13 looks like a rotation, but this time the center of rotation would have to be at P. If you're using patty paper, that's where the pencil would be pinned into it. So you rotate triangle PRQ about point P like this, such that Q maps onto N, or such that R maps onto M. Either one is fine, you don't need both. Remember this from yesterday, there are several ways to do this, and some of you found wild and crazy 2- and 3-step ways to do it, which is fine. There is a way to do it with 1 step, and that is to rotate triangle TUW about the midpoint of WU, which I have marked, such that U maps on to W, or such that V maps on to T. And try this one a little bit more on your own. You're taking triangle AEB and you're trying to map it onto triangle CED. So you're going to tell me you're going to rotate what about what such that what maps onto what. First, you want to pay close attention on 16A to the fact that J has to map onto F. So there isn't going to be any reflecting here because J is on the left and so is F. So all you need to do first is translate triangle JKL such that J maps onto F. That locks you into place there. And then your second step would be to reflect over line JK such that L mapped onto D. So this is a typical Regents question. Once you show how one maps onto the other, which we just did, they ask why are they congruent? They're congruent because we used a translation and a reflection, both which are rigid motions, and rigid motions preserve distance and angle, thus proving that they have to be congruent. There's no real trick on 17. They just want a single rigid motion that maps ABC onto EDF. Just be careful when you look that A has to map onto E. So remember from yesterday, it's not going to be just a translation. We have to get A onto E, which means there has to be a line in the middle that you reflect over. And that line in the middle is the perpendicular bisector of BD. So you are reflecting triangle ABC over the perpendicular bisector of BD such that A will eventually map onto E. Make sure you have all these done to show me on Monday. Have a good weekend.